We're going to look here at adding and subtracting decimals. So the most important thing to remember when we're adding and subtracting decimals using the standard addition and subtraction algorithms, we want to remember that we want to line up our place values, or in other words, line up your decimal points. And then that way, all the other place values will line up as well. So if we have subtraction with negative numbers, just make sure that you write the larger number first. And then you might also end up needing to attach some extra zeros just as placeholders. So like if we had, a whole number and we're subtracting a decimal number from it, it might make sense to write that whole number and then go ahead and insert a decimal point and put zeros behind it just so we have the same number of place values as we do in the number we're subtracting. Basically, once we have things lined up, you're just going to use the same standard algorithm that you used for whole number addition and whole number subtraction. So we're going to add or subtract the decimal numbers. We're going to do regrouping or exchanges just like we would with whole numbers. Remember the rules for negative numbers. Those are the same for decimals as they are for whole numbers. So remember, if the signs are the same, we add the two numbers. If the signs are different, then we subtract the larger one minus the smaller. And then either way, whether we have the same signs or different, we're always going to take the sign of the larger number, or technically the larger absolute value. And that's the sign that will go on our answer. And for the student that asks why, if you're wondering why this works, so remember that this number right here, for example, I would not say that as 0.4. We want to say that instead as 4/10, right? And then this one, we would say that as 8/10. So if I have 4/10 plus 8/10, this is just like if I had 4 apples plus 8 apples, right? 4 apples plus 8 apples would give me 12 apples. So if I have 4/10 plus 8/10, then that gives me 12/10, right? If I had 4 cars plus 8 cars, I'd have 12 cars. And if they're not the same, I wouldn't really be able to add them, right? Of course, I'm getting 12/10, but then technically we can regroup that, right? So we know that every 10/10 really equals 1 whole, right? So if we have 12/10, we really have 10/10 that gets regrouped as a whole, and then we would have 2/10 left over. So we would end up with 1 and 2/10, or we could write that as a fraction, right? And again, we would say that the same way, 1 and 2/10, or we know that decimals are just special fractions whenever the denominator is some power of 10. So here, since the denominator is 10, we could also write that as a decimal, and we would say that, and remember, instead of saying that as 1.2, we would actually say that the exact same way, 1 and 2/10, since the decimal point is the word and the 2 is in the tenths place. So let's do some examples where we're going to add and subtract with decimal numbers. So I'm starting with 3 and 49/100ths plus 1 and 8/10. So we're going to make sure that we line up our decimals. So we're going to line these up vertically. My decimal point in 1 and 8/10 is going to line up with the decimal in 3 and 49/100ths. So that means my 1 is going to go below the 3 and my 8 is going to go below the 4. And then we're going to add these together. So you don't have to, but I find that it is useful to go ahead and put in those 0 placeholders. So technically, even though we don't always write it there, we know there's technically a 0 in the hundredths place on 1 and 8/10. So it might be useful to go ahead and put that in there. And then we're going to basically add this as if this was whole numbers, as if we were adding 349 plus 180. So we would do this right to left. So I would add 9 plus 0 and get 9. I would add 4 plus 8, which is 12, and so I would regroup. So I would say that 12 is really one group of 10, so that would regroup one more in the next place value over, in this case in the ones place, and leave me with 2 left over. And then we just bring down the decimal, right? So wherever the decimal is in my problem, I would just line that up in my answer. And then I would add 3 plus 1 plus the 1 that I regrouped, and I would get 5 and 21/100ths. So this next one, I have 7 minus 6 and 95/100ths. For students that are really familiar with money, they could probably do this in their head, right? You could look at that as, oh, if I had $7 and I spent $6.95, my change is 5 cents. But if we're gonna technically show this, what I would do is I would go ahead and attach some extra zeros, just like $7 is really 7.00. But I would do that so that both numbers have the same number of place values, so that when I line up the decimals, there's a number in each spot, basically. All right, and then I'm going to subtract as if I were subtracting 700 minus 695. I'm just going to make sure that I bring the decimal down in my answer where it lines up. So technically the way you should do this is you should start right to left, and the first thing I would try to do is 0 minus 5, and realize that I can't do 0 minus 5 without getting a negative number, and I don't want a negative. So what I would do, since I don't have anything to take away 5 from, I would need to do an exchange. So I would go to the next place value over. In this case, I would go to the 10th place, and I would try to exchange something there to give me 10 more in the 100th place. Unfortunately, there's nothing there either, right? So when that happens, then I'm going to have to actually go over to the next place value. And if I had more zeros, I'd have to keep doing this. In this case, though, I can do an exchange in my ones place. And so that means I'm going to have one fewer in my ones place. So there's no way that I can make you do this, because when you have this turned into me, I'm going to just see the completed problem. So I won't know what you did first or second. But I would strongly encourage you not to go ahead and make this 10 here, because where did you get that 10? I really don't like the idea of putting something there before you've taken it from wherever you're getting it from, right? So it's like, how would you put $10 in your pocket if you hadn't borrowed it from someone else first, right? Or if you hadn't gotten it from someone else first. You have to get it from something in order to put it there. So I really don't like the idea of putting 10 there until I take it from someplace. So I'm going to take 1 away from the 7, so that's going to leave me with 1 fewer, which is 6. And so taking 1 from the ones place would give me 10 in the 10th place, in the next place over. So add that to the 0 that's already there, means that now I would have 10 in the 10th place. Now that's great, but I still can't do 0 minus 5 and get a positive answer. So I still need to do an exchange. So then I would again go through and say, okay, can I exchange something for my 10th place? And now I can. Now there's something to exchange. So now I could exchange one of those 10, which means now there's going to be 9 left in the 10th place. And then that would give me, for every 1 in the 10th place, that would give me 10 in the 100th place. And I also really like crossing out the 0 rather than just writing a 1 next to it, because that emphasizes the fact that I'm actually adding it to 0, right? I'm adding the 10 to the 0 and getting 10. And at this point, I can just do my subtraction. 10 minus 5 is 5, 9 minus 9 is 0, 6 minus 6 is 0. And you could leave your answer like that, or you could also, if you don't write the 0 in front of the decimal, that's also fine. All right, and then this last example, it involves the negative. So keep in mind, if you're struggling with negatives when you have decimals, go back to not decimals, right? So go back to something like -3 plus 2, right? When you don't have decimals there. And remind yourself of what you would do there. So -3 plus 2 would be -1. So I would expect here my answer is going to be close to -1. So that can help keep you on track in terms of your rules for applying negatives. So I know that when my signs are the same, I add. When my signs are different, I actually subtract, right? So in this case, my signs are different because 3 5/10 is negative, but 2 81/100 is positive. So because I have different signs, I'm going to subtract, and I'm actually going to subtract larger minus smaller. And when I say larger minus smaller, I mean ignoring the signs. I mean larger absolute value minus smaller absolute value. So I would actually be doing 3 5/10 minus 2 81/100. I'm going to go ahead and put a 0 placeholder there next to the 5, just so I have the same number of digits in all the place values that are showing here. And then I'm going to go ahead and do this subtraction, but I'm going to have to remember in the end whether my answer is going to be positive or negative. So in this case, since I have the larger absolute value is 3.5, 3.5 is a larger absolute value than 2 81/100. And since that is negative, that means my answer is going to be negative. So if you want to go ahead and put that so you don't forget, I'm going to be subtracting, but then I have to remember to put that negative on my answer in the end. In this case, I am going to have to do some exchanges, so I can't do 0 minus 1 and get a positive, so I'm going to take 1 from the 5. I know we used to call that borrow, but we don't like that because it's not very precise language, and if you think about it, I don't plan on giving it back, so why would I call it borrowing? So I'm going to exchange one of those in the tens place, which gives me 1 fewer, so now I have 4 in the tens place. That gives me 10 more in the hundredths place. Add that to the 0 I already have, means I'll have a total of 10 there. And now I can do some subtraction. 10 minus 1 would give me 9, right? 10 hundredths minus 1 hundredth would be 9 hundredths. And then I would like to do the tenths and subtract those, but if I subtract 4 tenths minus 8 tenths, again, I can't do that and get a positive, so I'm going to do another exchange. I'm going to exchange 1 here, which gives me 2. That's going to give me 10 more in the tenths place, but I need to add it to the 4 I already have, which means now I have 14. So now I can do the subtraction. 14 minus 8 is 6. Bring my decimal down, and then 2 minus 2 is 0. Again, you don't have to write the 0 if that's all that there is in front of the decimal, but you do need to remember that it is negative in this case. And yes, that is reasonably close to -1. So we know we did this correctly.